After the short and simple introduction on synthetic fuel, also called e-fuel, let's dive in to do a deeper analysis to compare it with the other main alternatives to fossil fuels, hydrogen and electric. Let's start with hydrogen. Hydrogen is said to be perfectly clean, because when it burns it emits only water, but that's just part of the picture. The first problem with hydrogen is it doesn't exist in a natural state on Earth. There is no hydrogen mine or giant pockets of natural hydrogen in the ground. It has to be synthesized. Therefore, hydrogen is also a synthetic fuel, just like synthetic gasoline. Ironically, hydrogen is by far the most abundant element in the universe. About 75% of the known universe is made out of hydrogen. Stars and giant gas planets are mainly made of hydrogen, but sadly it doesn't exist in a natural state on Earth. We have to synthesize it. As seen in part 1 of the video, hydrogen gas can be very easily obtained, for instance by running an electric current in water. If this electric current comes from green energy, then the obtained hydrogen is clean. Otherwise it's dirty. Hydrogen wins the manufacturing contest as it's way simpler and easier to obtain than synthetic hydrocarbons. But even if it is produced using green energy, the biggest problem with hydrogen is its storage. Hydrogen is a gas in ambient conditions, an extremely light gas, much lighter than air. 1 meter cubed of hydrogen weighs only 90 grams in ambient conditions. That's over 14 times lighter than air, which weighs around 1,300 grams per meters cubed. In fact, hydrogen, or rather dihydrogen, to give it its real name, is the lightest gas there is. In other words, 1 cubic meter of pure hydrogen gas contains only 90 grams worth of atoms, that is, 90 grams of fuel. So if you want to embark on obtaining a decent quantity of hydrogen fuel for a car, then you must compress an enormous volume of gas into a small tank. Fortunately though, hydrogen has an extremely high energy density, which means you don't need a lot of fuel mass to power a car or truck. To reach a range of 500 kilometers, you need just 5 kilograms of hydrogen fuel. But 5 kilograms is 55 meters cubed of pure hydrogen gas. If you manage to compress all this gas at enormous pressures of 70 megapascals, which is doable but colossal, that's 700 times the atmospheric pressure at sea level, then you'll make all this compressed gas fit into a 125-litre tank. The tank will need to be able to withstand the pressure and will still be over twice the size of a regular car tank, around 50 litres, which means firstly, it's not very safe aboard a car, and secondly, you need a very sturdy and heavy tank. Besides that, a lot of energy is required to compress the gas, which adds up to the energetic bill and overall complexity of the process. You could go all the way and liquefy the hydrogen so it comes out as liquid instead of gas. In this case, you don't need a pressure-resistant tank, but the liquid needs to be maintained at minus 253 degrees Celsius, only 20 degrees above absolute zero. Needless to say, that is pretty much impossible in a car and is reserved to very specific applications like space rockets. And liquefying hydrogen requires another substantial amount of energy, and that also adds to the bill. So, compared to hydrogen, gasoline has at least one obvious considerable advantage. It comes in liquid form at ambient temperature and its storage is extremely easy. Storage difficulty is the real hydrogen killer. It also makes refueling very problematic because you have to refuel your car with an explosive gas at extremely high pressure. What could go wrong? Another hydrogen killer. Infrastructure. All the infrastructure for hydrocarbon fuel is already in place. We have gas stations and everything. No need to build special gas stations that can store hydrogen under extremely high pressure, with all the complications and costs that it entails. There's no contest here. A word again about energy density. 1 kilogram of gasoline contains much less energy than 1 kilogram of hydrogen. About 3 times less in fact. 45 megajoules per kilogram for gasoline and 120 megajoules per kilogram for hydrogen. So you need a lot more hydrocarbon fuel to drive the same distance. But this is still a fairly big amount of energy, way more than what kilograms of lithium-ion batteries can store. The technology has evolved a lot, but to this day, in 2022, it is still less than 1 megajoule per kilogram. Which will bring us on to part 3 of this video, the comparison with electric cars. I'll see you there.